Hi, I'm Stephen Hillion. I run data and AI for Astronomer. We're the commercial developer behind Airflow, the open source workflow and orchestration platform. How many people have heard of Airflow? Oh, then that's half my presentation gone. So probably then, I'll give a brief introduction to Airflow, then I want to talk a little bit about applications that I've seen, including some that we've built ourselves for operationalizing machine learning and generative AI pipelines. For those who are not super familiar with Airflow, the two of you, it's open source. It's largely used for data engineering and machine learning pipelines running operationally. So I don't need to tell people the importance of data pipelines. They run the world. Most modern organizations, the lifeblood of the business that they do, everything that feeds your applications is the data pipeline. So Lyft, for example, every interaction that you have on the Lyft application is powered by a data pipeline producing data sets, statistics, custom models, running predictions. Thousands of pipelines that essentially are what Lyft does. It's really a data company. If you think of Walmart, you think of Walmart as being the experts when it comes to supply chains, but they also have supply chains of data. So they have literally tens, if not hundreds of thousands of data pipelines built by about 600 data engineering teams, making sure that merchandise arrives on the shelves in time for the holidays and that the prices are correct. FanDuel, the sports betting application, they, in order to make a profit, need to make sure that they're constantly arbitraging the odds that they're giving out to their customers, to their users, to make sure that they make a profit. All of that driven by machine learning pipelines. Amazon is building a new search interface powered by large language models, a more advanced sort of shopping equipment, all depending on data pipelines. In every single one of those cases that I just told you about, those pipelines are running on Airflow. So Airflow powering data engineering, powering statistics, powering Walmart's supply chain, powering Amazon's large language models. What is Apache Airflow then? As I mentioned, it's the most successful, it's an open source project, it's the most successful, by some measures, open source project on Apache in history. Surpassed Spark, for example. And again, Astronomer is the commercial developer behind that. We make most of the commits, more or less most of the commits to the Apache project. Okay, let me talk about a specific example. So I've mentioned a few examples. I mentioned Amazon, I mentioned FanDuel. FanDuel is a great one. I mean, really lots and lots of predictive models that are powering everything that happens to the application. But a company you may not have heard of, Laurel, is actually my favorite application. And that's because they've, first of all, solved a very cool problem. And secondly, because they really have built an entire MLOps framework with Airflow from the ground up. Now, in many of the cases that I just mentioned, Airflow is really being used as the orchestrator that brings together data engineering pipelines, machine learning pipelines that may call out to SageMaker or to Weights and Biases or to Metaflow. And it's really then the orchestrator. It's a little bit out of remove. But that's not always the case, and in many cases people actually use the extensibility and the openness of Airflow as an open source framework to build their own MLOps capabilities on top of that, and that's true for Laurel. So I don't know if you're aware of how lawyers work, right? Every 6 minutes they have to report on what they're doing so that they can charge the client, and it's an incredibly tedious process, and then they have to send a summary of this to the client at the end of the day to justify the thousands of dollars that they're billing them. It's exactly the sort of tedious rote operation that machine learning and for summarization that large language models were built for. So they have to build these models offline, but they have to remain very current and very fresh because companies, legal companies, accounting companies, will be changing projects from time to time. They'll be bringing new organizations, new clients on. The nature of their work may change over time, and you want to have those models to be highly contextual and highly reflective of the most recent projects or clients or contexts. And so they rebuild all of their models, large language models fine-tuned, as well as traditional models for doing the 6-minute reporting. They build those on a daily basis. So it'll look at what actions users are taking, the windows that they open, what they write, how much time they spent on Zoom, and make a prediction that, well, you're talking to a client or you are writing a brief or whatever it might be. and then they automate those timelines. So those models are built pretty much for every client, sometimes even at a finer level of granularity, so hundreds if not thousands of models being rebuilt daily. All of that gets automated through Airflow DAGs using essentially sort of a map-reduced structure that you have in Airflow. And then there's a separate DAG that runs, a single DAG, which they call their metrics DAG, which constantly monitors all of those models, treating them as challenger models and comparing them to ground truth and determining if the new model trained on the most recent data meets a certain level of quality or beats the champion. So this champion-challenger approach is again governed through that pipeline that's running in Airflow. The large language models, the fine-tuning, all of the actual training of the model actually happens outside of Airflow, but the data preparation, all of the feature generation, and the corralling of all the data from all those hundreds of different clients is again managed by Airflow. And I should say by Astro, which is our platform. So it's really a complete MLOps solution. And if you think about all the things you have to get right to do MLOps, there's a lot of things. But essentially, in Laurel's case, and all the ones that I've just been mentioning, that checkbox is all stuff that the Airflow platform is managing. All of the data prep and the ETL, the things that historically have been associated with Airflow, but also the model training, even the compute for the small models, those just happen in Python functions in memory within the Airflow cluster, and others are pushed out to Kubernetes, but still managed by Airflow and Astro. Astro is the name of our cloud platform that runs Airflow. The model versioning is stored within buckets that are managed by the Airflow pipelines, and so on and so on. You get the point. It's absolutely mission critical, just like Lyft and all those others I mentioned. These models are what Laurel does. They're not like there to make the business better. They are the business. And so these are absolutely mission critical. You cannot have a pipeline go down. Or if it does fail, maybe because of some rate limit or some interruption, you need to be able to make sure that that's trained. And if something does go wrong, to make sure that you have logs that you can go in and investigate and fix things quickly. So all of that scalability, scaling up and scaling down so that compute can be used for your models without having things just spinning and consuming, all of that is built into the platform, that reliability and that auditability. I think in many cases people don't necessarily think of Airflow specifically in the context of machine learning, but if you think about it, a lot of the disciplines that you need to do machine learning operations are the very same disciplines that you need: transparency, reliability, auditability, open extensibility that you need for data engineering and traditional data pipelines. Okay. In the last 2 minutes, I want to talk about what my team is doing. So I run the data science team at Astronomer that actually, of course, uses Airflow to manage all of our things. Dashboards, reverse ETL of predictive models into Salesforce, and Ask Astro, which I'll talk about in a second. We have a notebooks interface for actually writing Airflow DAGs. And it's cool. It's just like any other sort of Jupyter notebook, but it'll turn your notebook into an Airflow DAG and just operationalize it automatically. So it's a great way to get data scientist stuff into production. But you can actually now type in what you want to do. Say, I want to send an email when this DAG has finished, and it'll generate the cell for you and create a form for you to fill out to add that to the end of your flow. Or if you just want to write some Python code, you can also add that prompt, and it'll write the code for you and inject it into the flow as well. So standard sort of RAG-style approach for doing code generation within our notebook interface. Ask Astro has been released now for a few weeks. It's a conversational AI assistant like we're all trying to build using our own internal documentation as well as public documentation for Airflow. So you can ask questions, you can go to our website and try that out, and we actually released it on the Apache Airflow Slack, the public community. We released it yesterday, so you can go and interact with that chatbot and ask questions about Airflow. One of the primary contributors and one of the inventors of Airflow just gave it his seal approval this morning, so we're feeling pretty happy about it. All of the flows that power those things that I just showed you are running through Airflow. So this is pretty meta, right? You have people asking questions about Airflow through an application that is powered by Airflow. So that's how we use LangChain, OpenAI, and Weaviate. Very standard. I'm not going to go into the details. You've seen this flow before, but it's embedded within these Airflow DAGs. The application is run not through Airflow. This is all real time, and so this is just pinging the vector database that we've created. And then finally, the feedback, taking thumbs up and thumbs down, feeding those back into the Weaviate database is all, of course, handled by Airflow. The main point I want to make is you can go and try this out on the Apache Airflow Slack community or on our website. All of the source code is for you, free. You can use it. If you want to operationalize your machine learning pipelines, we've done the work for you. All the ingestion, the embedding, the vectorization, and the retrieval and the feedback loops. So go and check it out. This website has the link to the GitHub repo. Okay, thanks very much.